Hey guys, Mr. Backerwork here. In this video, we're going to look at finding some trig function values of special acute angles. Now, as we're talking about special acute angles, there's actually three different angles that we're going to talk about, and we're going to start with a 30-degree angle. Now, back in geometry, we dealt with two special kinds of right triangles, and one of them was a 30, 60, 90 triangle. So I'm going to draw out a 30, 60, 90 triangle. So it's going to look something like this. This angle down in the bottom left-hand corner, I'm going to say is 30 degrees. This angle on the top right-hand corner is 60 degrees, and this angle on the bottom right is a 90-degree angle. Now, we had a side-length relationship in our 30, 60, 90 triangle, and it was all based on the short side. And the short side of this triangle is the side across from that 30-degree angle, and we called that side our x, and that just meant some general length. And then the other two sides of this triangle were based on whatever that x value was. The hypotenuse, so across from the 90-degree angle, was always twice as long as the short side, so I'm going to call that 2x. And the side across from the 60-degree angle was whatever that x value was times the square root of 3. Now, as we're looking at setting up our trig ratios using this special right triangle, I'm actually going to focus on the most basic form of this 30, 60, 90 triangle. And that's where this x value is going to be 1. So what's going to happen in here is, instead of just having this x on the right-hand side, we said that x was going to be 1. Now, if I take 2 times x, or 2 times 1, then this length of the hypotenuse is just going to be 2, so I can get rid of that x in there. And then along the bottom here, across from that 60-degree angle, if I take 1 times the square root of 3, then that side length is just going to be the square root of 3. Now, what we're going to do is focus on this 30-degree angle down in the bottom left-hand corner, and we're going to do all of our trig functions for that 30-degree angle. So we're going to do the sine of 30 degrees, we're going to do the cosine of 30 degrees, and we're going to do the tangent of 30 degrees. And then once we have all those done, we'll do our reciprocal functions as well. Now, as we're focusing on this right triangle to do the sine, the cosine, and the tangent, I'm going to use SOHCAHTOA to help me out. So for the sine of this 30-degree angle, sine, that SO portion, I'm supposed to take the opposite side over the hypotenuse. So opposite of that 30-degree angle is 1, and the hypotenuse length is 2. So the sine of 30 degrees is 1/2. And that's actually going to be true for every single 30-degree angle. Now, if I do the cosine of 30 degrees, that ca portion, I'm supposed to take the adjacent side over the hypotenuse. So the adjacent side right next to the 30-degree angle is the root 3, and the hypotenuse is still 2. And again, this is going to be the cosine for every single 30-degree angle. Then for our tangent, that TOA, we're supposed to do the opposite over the adjacent. So the opposite side is 1, and the adjacent side is the square root of 3. Now, we don't typically like to leave radicals on the bottom of this fraction, so we could rationalize this by multiplying top and bottom by the square root of 3. So then we would end up with root 3 over 3. Now, I said we were also going to do those reciprocal functions as well. So the reciprocal of the sine is the cosecant. So the cosecant of 30 degrees. Reciprocal means I'm flipping that fraction over. So that's 2 over 1, but that reduces down to just 2. The reciprocal of the cosine is the secant, so the secant of 30 degrees. If I do the reciprocal of this, I'm going to get 2 over the square root of 3, but we don't typically like to leave radicals on the bottom, so I'm going to multiply that root 3 up to the top. So we're going to get 2 root 3 over 3. And then the reciprocal of the tangent is the cotangent of 30 degrees. Now, with the tangent, we actually cleaned this fraction up a little bit to get that radical off of the bottom. I'm actually going to focus on this 1 over root 3. That's going to make doing the cotangent a little bit easier. If I just flip over this original tangent fraction, then I'm going to get root 3 over 1. But then since we're dividing by 1, that's just going to turn into the square root of 3. So these trig function values will hold true for every single 30-degree angle because it's all based on that 30, 60, 90 triangle. While we're talking about a 30, 60, 90 triangle, our next special acute angle is a 60-degree angle. So I'm going to draw that exact same 30, 60, 90 triangle that we just got finished working with. Last time we focused on the 30-degree angle. This time we're going to focus on the 60-degree angle. So this 60-degree angle, we're shifting our focus a little bit. So when we do our trig functions, we're going to end up with some different values in here. So we're going to do the sine of 60, the cosine of 60, and the tangent of 60. And then once we have those three values, we do our reciprocals as well. So using our triangle, we will have to do SOHCAHTOA again. So I'm going to write this out real quick. If we do the sine of this 60-degree angle, we're still doing the opposite over the hypotenuse. But since we've shifted our focus up to this 60-degree angle, now the root 3 is the opposite side. So it's going to be root 3 over the hypotenuse of 2. For the cosine of 60, now 1 is the adjacent side over the hypotenuse of 2. And then for the tangent of 60, opposite is root 3 and adjacent is 1. But root 3 over 1 is just the square root of 3. Now we are going to do our reciprocals as well. So the reciprocal of the sine is the cosecant. So the cosecant of 60, if we flip that over, we're going to get 2 over root 3, but we're going to have to rationalize this to get that radical off of the bottom. So we're going to get 2 root 3 over 3. The reciprocal of the cosine is the secant. So the secant of 60 degrees, that's going to be 2 over 1 if we flip that fraction over, but that reduces down to just 2. And then for the cotangent of 60 degrees, if I flip over this root 3 over 1, then I'm going to get 1 over the square root of 3, but I can't leave that radical on bottom, so I'm going to rationalize that to get root 3 over 3. And again, these function values will hold true for every single 60-degree angle. Now, our last special acute angle that we need to talk about is a 45-degree angle. So again, back in geometry, we had a special right triangle that had 45-degree angles in it. It was a 45, 45, 90 triangle. So this angle on the bottom left is 45 degrees. This angle on the top right is also going to be 45 degrees, and then we've got our right angle down on the bottom. Now, since we've got two angles that are congruent, this triangle is isosceles, meaning that we're also going to have two congruent sides, and it's going to be the sides across from those 45-degree angles. So these two sides are going to be the same length, and that's actually what we based this triangle off of. So we called those legs both x, and then for our other side, that hypotenuse, what we did is took x times the square root of 2. Just like we did on our 30, 60, 90 triangle, though, in order to make the trig functions a little bit easier, so that we don't have to do as much reducing and work with our fractions, we're going to deal with the simplest form of this 45, 45, 90 triangle. So what we're going to do in here is we're going to let this x value be 1. So this leg is going to be 1. This leg down on the bottom is going to be 1. And then if I take 1 times the square root of 2 for that hypotenuse, we're just going to get the square root of 2. Now I can start doing my trig functions. So we're going to do the sine of our 45-degree angle. We're going to do the cosine of 45, and we're going to do the tangent of 45. And then once we get those set up, we will do our reciprocal functions as well. So for the sine, we're going to look at one of these 45-degree angles, and it actually doesn't matter which one we focus on. So let's just do this one on the bottom left-hand corner. So if I do the sine, we're supposed to do the opposite side over the hypotenuse. So I'm going to take 1 over the square root of 2, but we don't like to leave that radical on bottom, so we're going to rationalize that to get root 2 over 2. Now if I do the cosine of 45, cosine is adjacent over hypotenuse. Since that adjacent side is 1, we're going to get 1 over root 2 again, and that's going to rationalize to be root 2 over 2. And then for the tangent, we do opposite over adjacent, so we're going to do 1 over 1, but 1 divided by 1 is just 1. Now we're going to do our reciprocal functions, so the reciprocal of the sine is the cosecant of 45, and I'm going to go back to this unrationalized version of this fraction and flip that one over. So if I do that, I'm going to get root 2 over 1, but root 2 divided by 1 is just root 2. Similar things are going to happen as we look at the secant of our 45-degree angle. If we look at this unrationalized version of this fraction and flip it over, we're going to get root 2 over 1, but that reduces down to just root 2. And then if we do the cotangent of our 45-degree angle, flipping this fraction over, we're still going to get 1 over 1, which is an answer of 1. That's going to be it for this video. Thanks for watching.